Okay, everyone, it's 101, and we're going to go ahead and get started. My name is Oakley Weddle, and I'm organizing this event, and I'm the marketing manager at ProTech Services Group. I'm going to turn it over to Chris Bradley. Chris?
Good afternoon, and welcome to our webinar, Is Your SQL Server the Common Issues That May Be Putting Your Data at Risk? Joe, could you go to the next slide, please? So my name is Chris Bradley. I'm the VP of Managed and Cloud Solutions here at ProTech. And before we dive into today's topic, I want to take a moment to introduce ProTech to those of you who may not already be familiar with us. ProTech Services Group is a technology services firm with 29 years of experience focused on understanding the technology needs of business and applying a range of innovative solutions designed to help drive them forward. With a wide range of services and solutions, some of our core areas of expertise include managed services ranging from fully outsourced IT operations to custom services designed to meet specific customer needs, cloud solutions from infrastructure as a service from large public cloud providers such as AWS and Azure, to enterprise cloud and a variety of SaaS solutions. Security solutions include our managed security stack, utilizing a layered approach to protecting IT and data assets, security assessments, compliance SIM and SOC services, and security awareness training and testing. Also, carrier and voice services, providing consultative analysis and cost optimization for internet and telecom services, premise-based phone solutions, and cloud-hosted voice and other call center solutions. Technology and consulting services, which range from small to large-scale IT projects to consultative engagements in any of our areas of expertise. And talent acquisition. With a full-feature staffing division, we're able to assist with temporary and permanent placement of resources, with talents ranging from IT and finance to the executive level. Lastly, ProTech prides itself in being an integral part of the community through its ProTech Cares initiatives, supporting organizations like the Boys and Girls Clubs of Memphis, Streets Ministries, St. Jude, and the National Civil Rights Museum, to name a few. It is within our core values to be a true technology partner and help organizations leverage technology to achieve profitability, growth, and security. So today we're excited to have Joe Webb with the SERO Group with us to discuss common issues that may be putting your SQL Server data at risk. Joe?
All right. Thank you very much, Chris. Let's see here. There we go. So yes, today I'd like to spend just a few minutes, maybe half an hour with you or so, talking about some of the common issues that we see in our SQL Server practice. Common configuration issues that may be causing potentially disruptive events or putting your data at risk inside your Microsoft SQL Server. A lot of organizations these days are becoming more and more reliant upon Microsoft SQL Server, whether it's in the healthcare industry with EMR or EHR records, practice management systems, transportation, logistics, legal, banking, import, export. All of those industries are becoming more and more reliant upon the data that SQL Server is housing for them. And so if that SQL Server foundation is configured poorly, then just like the foundation of a house that's not quite stable, the entire structure or infrastructure, data landscape is going to be put at risk. And so I'd like to share with you some of the things today that we find that are commonly overlooked configuration or management settings within some of the SQL servers that we're assessing. So once again, as Chris had mentioned, I'm Joe Webb. I've spent the last 25 years or so doing Microsoft SQL Server consulting and have been a part of a lot of organizations, both here in the United States and worldwide, for furthering the SQL Server community and the product itself. Spoken at a lot of different conferences over the years, but really enjoy in my professional life working with Microsoft SQL Server and their users and those companies that depend on SQL Server to help them get the best out of it. So our company is the SERO Group, and I won't spend a lot of time here, but we do SQL Server, and we only do SQL Server. We do SQL Server assessments where we work with an organization. We have some scripts that we use that we'll run that'll collect some configuration information and compare those configurations to industry normed best practices, and then highlight any departures from that 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 the organization may want to address. We also do SQL Server consulting. So we do project-based work, for example, helping our organizations with upgrades or helping them to configure disaster recovery or high availability solutions, maybe configuring some availability groups or failover clustered instances, things like that. And a core part of our offering is DBA as a service, where we provide remote database administration services on a fractal or part-time basis for companies that don't necessarily have the need or the budget for a full-time database administrator. So let's talk about what we're going to, the objective or the goal for today's session. Today's session is broken into 4 different larger components, if you will. We'll talk about some of the common causes for some of the configuration issues that I'm going to share with you, how we end up or how SQL Server ends up with some of these configuration settings that may not be optimal for any particular environment. We'll talk about some common configuration issues that we see, some maintenance issues, and then some business issues as SQL Server relates to supporting those, the business users and the stakeholders within the organization, some of the misalignments that can be found there. So some of the common causes for the configuration and maintenance issues that we're seeing. Well, SQL Server, first off, is very, very easy to install and set up. I remember many, many years ago teaching a class of for SQL Server to a bunch of Oracle DBAs. And when we got to the portion of the 40-hour class where we were going to install and configure Microsoft SQL Server, it only allocated a couple of hours for that task, for that lab. And the class was just incredulous that SQL Server could be installed and loosely configured in just a couple of hours. And as we went on through it, they were kind of shocked that we were able to get through that. We didn't have to do a lot of the complexities that at least used to be as part of the Oracle setup routine. But unfortunately, SQL Server being so easy to install and configure, or at least install, is where a lot of people stop. They will put in the media and click next, 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 next. And next thing you know, after 15, 20 minutes, you've got a fully functional Microsoft SQL Server installed. Or maybe you've downloaded a Docker container from Microsoft. Fire up the Docker container, and now you've got SQL Server up and running. Unfortunately, though, when we take that approach, SQL Server's defaults are not necessarily the optimal for any particular environment. And we'll highlight some of those as we go a little bit further. But unfortunately, a lot of people stop with just the installation. Once they've stopped with just the installation, SQL Server just works. It's a testament to the SQL Server program team. It's a testament to the product itself. You can kind of set it up, run it, even neglect it to a certain extent, and it's going to run pretty well and be pretty resilient until it's not. And so, it's a case where a lot of times companies will start it off and then just simply not do anything with it until it becomes a problem. A lot of organizations also will have a what we sometimes call an accidental DBA, meaning that someone is tasked or charged with taking care of the SQL Server database, but it's not their full-time job. Maybe it's a systems administrator, a Windows administrator, network admin, a programmer, developer, maybe it's the CIO. They're doing this in a part-time basis, even though SQL Server is a complex system, it's a very broad SKU with a lot of different components, a lot of different aspects to it. And unfortunately, when it becomes someone's part-time job in their spare time, a lot of times SQL Server kind of gets neglected because if it's not broke, why fix it? And so, the emphasis on, we're all busy people. And so if it's being taken care of by a part-time, someone in their part-time, then it can be neglected over time. Additionally, with when there are minor issues with SQL Server, maybe it's not performing as well as your users would expect, or maybe there's some minor issues here and there. A lot of times, particularly in a virtualized world, it becomes very easy just to turn a knob and all of a sudden you've gone from 12 CPUs to 16 CPUs, or you've gone from, 32 gig of RAM to 64 gig of RAM. And it's pretty easy to scale up like that by just throwing hardware at the problem. Frequently that works, but as you continue to grow and the usage continues to increase, and particularly if you're considering going to the cloud where you pay by resource consumption, then throwing hardware at it becomes very, very expensive. Additionally, throwing hardware can change the licensing within Microsoft, so that can become a problem for you. And finally, over time, as people come and go within the organization, different people within the organization or even outside of the organization have set up SQL Server, they may do it with their own standards. And so, one DBA may do it with this standard, a sysadmin may do it with another standard, a vendor may come in and set it up with yet their own third standard. And so pretty soon we end up seeing a lot of different, quote, standards being applied in one environment. I don't remember who originally said it, but there's a quote that I think is pretty apt. It's, the wonderful thing about standards is there's so many to choose from. And so, again, a lot of people will set up their own standards, and those standards may or may not adhere to best practices. So let's dive down into some of the common configuration issues that all of those things can lead to. So here's kind of the things that we see when we do our SQL Server assessments. One of the first things we notice is the SQL Server version or patch level. Microsoft has regularly releases cumulative updates and hot fixes along the way. And, sometimes those can be difficult to keep up with, particularly if you're in a production environment where you've got multiple versions of SQL Server running to support different customer or different client applications and so forth. And, none of us really want to rush in and install a cumulative update on a production system without first checking to make sure that there's no ill side effects to it. So we want to put it into a test environment, test it out, make sure it's going to work, make sure everything's going to perform well, and then apply it into the production environment. Sometimes that creates a certain amount of friction, and organizations can get behind on applying those patches. As crazy as it seems to me, SQL Server 2016, which doesn't seem like it was released that long ago, is actually going out of mainstream support next month. So it'll have another approximately 5 years worth of extended support, but still, staying up and doing those upgrades along the way, applying those cumulative patches along the way, those cumulative updates along the way is incredibly important. Not only for security aspects, but for reliability and performance as well. Now, the second thing that we see quite often is when SQL Server is performing well and a lot of times we may not notice if problems begin to arise or issues begin to pop up that are not really disruptive in nature yet, but they could be if not addressed quickly. And unfortunately, a lot of times SQL Server has no way to really communicate with the outside world to notify system admins or users that potential problems are popping up. Of course, SQL Server will log everything into its event logs. The SQL Server error logs is what they call it. But unfortunately, not a lot of companies will check those on a daily basis. We do recommend it, but not a lot of companies check the error logs on a regular basis. And so SQL Server needs some way to communicate with the outside world to let you know if something begins to go sideways. So the way they do it in SQL Server's world is database mail. You configure alerts and notifications if a job fails, if corruption is beginning to be seen, if a database integrity check fails, things like that. Along with that, it's important to create what's called a failsafe operator. So in SQL Server, what happens is if a job fails or some other alert needs to go out, it will use database mail to do that. And it checks a system database called MSDB to see who should I email about this problem. Should I email Chris? Should I email Joe? Should I email Luke about this particular problem? Well, if MSDB is the database that is having the issue, SQL Server has no place to go to ask, who should I email? So the failsafe operator is configured outside of MSDB so that it always has somebody to email. If no one else is available, if it can't determine who to email because MSDB is the problem, email this person. And we see that setting is regularly neglected. An issue that can affect performance is actually outside of SQL Server. It's in the Windows world. So we often see that the default performance setting for a Windows server is balanced, and which means that Windows can scale up and down the speed of the processors and some other resource levels according to need. And so it will scale back at times when it believes that the additional resources are not needed. That could save energy, save on heat and some other things as well. But unfortunately, for a resource-intensive service like Microsoft SQL Server, that can have some pretty dramatic effects on the performance and response times within SQL Server, particularly if it's being scaled up and down quite a bit throughout the day. So what we recommend is go into the Windows settings and set the power settings to high performance plan for your SQL servers. For other servers, your file servers, probably not necessary, but for Microsoft SQL Server, it'll pay dividends. TempDB. TempDB is a database. It's kind of like a scratch pad or a workspace for Microsoft SQL Server. When it needs to do some additional computations, to do some complex joins, to do some complex order bys or sorting, some other operations, either implicitly or explicitly, it'll do that within the Microsoft SQL Server TempDB database. By default, in some of the earlier versions, in 2017 and earlier, Microsoft only created one TempDB data file. And that could be a bottleneck since all databases share that one TempDB. All of those are hitting that one TempDB. You could have some contentions inside that database. And so by default, we recommend that you have more than one. In 2019, the setup does allow you to adjust it during the install, whereas before it did not. We recommend starting typically, depending on the size of the system, but for most systems, we typically recommend setting up 4 data files for your TempDBs, all the same size, all with the growth patterns that make sense, rather than percentage, do it by a block at a time, things like that. There is no reason to create multiple log files for your TempDB. Just one log file is sufficient, but multiple data files is definitely worthwhile. Another performance-related item that we see that you may have heard about is MaxDop and cost threshold for parallelism. So those are settings when SQL Server receives a query from a user. The query optimizer will take a look at it and do something called cost-based optimization. Cost-based optimization means that the optimizer is going to look at a bunch of different ways that it could actually go about resolving this query. Join these 2 tables and then this other 3rd table, or maybe we want to do it in a different order. Maybe some of the joins will be done in different ways. There's nested loop joins and hash match joins and a bunch of different internal things that could affect the way SQL Server resolves the queries. One of the things that it can do is decide to resolve that query either in a single thread or spread it out across multiple threads. And sometimes a single thread is more efficient than multiple threads, and other times the reverse is true. MaxDop tells SQL Server how many processors, how many degrees of parallelism should it consider available. Should it spread out among all the different processors, just a subset of the processors? How many are available for large queries? Cost threshold for parallelism works in conjunction with MaxDop, and it says, for my system, what should we consider a large query? By default, cost threshold for parallelism has a setting of 5. That's generally way too small. We recommend setting it somewhere between 35 and 40, maybe even 50, depending on how you use your system. In MaxDop, there's settings that Microsoft has some recommendations for that you can download and take a look at. Has to do with NUMA nodes and CPUs and a lot of other things, but generally speaking, probably somewhere between a setting of somewhere between 4 and 8 is good, depending on how many CPUs you have. MaxDop MaxDop has a default of 0, which means it will take all the CPUs that it can get its hands on. Generally, probably not the best solution for you. Next, we find that CPU alignment. So Microsoft SQL Server Standard Edition is limited or constrained by the amount of memory it can use and the number of CPUs that it can use. SQL Server 2016, for example, is limited to the lesser of 4 sockets or 24 cores. Sometimes what we see is a mismatch there, and a virtual machine will present to SQL Server maybe 8 cores with, 8 sockets with 2 cores each. Well, SQL Server is not going to be able to use all of that. It can only use a total of 4 sockets. And so by reconfiguring the virtual CPUs to maybe present that in a slightly different way, you'll be able to get more CPU utilization available for SQL Server. And the final thing that we notice here within the configuration is the SQL Server logs. By default, SQL Server will keep 6 log files. So every time SQL Server starts up or has a minor issue or completes a job or whatever, it begins logging that information to a text file that we can review if we believe that there may be some issues that SQL Server is having. By default, it'll only use 6, and it only recycles those logs or creates a new log whenever the SQL Server service is created. We generally configure our systems to where we keep 30 log files, and we create a scheduled job that'll cycle a new log every day. So we can look back. It keeps the logs manageable in size so that we can easily go back and look at them if we need to, but keeps them long enough of a history to allow us to go back and look, for up to 30 days to see what may have happened if anything unusual was noticed. So let's talk about some common maintenance issues that we see. We frequently see that the defaults are kept within SQL Server, and so all of the binary files for SQL Server are on the C drive. So's the default files for both log and for data and for backups and everything else. And so everything is on the C drive frequently. Or maybe you've spread it out and they're on, the operating system's on C and the binaries are on C, but the data and log files are there on a D drive. Unfortunately, when the data files and log files are on the same drive, that even if the drives can perform well, they do have very different usage patterns. Log files are typically more sequential in nature. Data files are typically much more random in access. So you're causing a lot of different types of activity. But additionally, for resiliency, you would like to spread those out so that if any one disk goes down or any one partition goes down, you still have access to the other. We also see that some databases that are configured for full recovery mode may not be backing up the log files. And so if that's the case, then the log files can grow considerably large and will grow unbounded until they eventually fill up that disk, in which case SQL Server will take that database offline. So if you're using simple recovery mode, no problem. You only have to worry about backing up the data file itself. But if you're using full recovery mode, which you probably do want to do for most critical applications, then it's important to back up both the data and the log files. The query optimizer that I mentioned before makes decisions about how to resolve a query based on statistics. If the statistics are bad, then it'll make bad decisions, and bad decisions will lead to poor performance. So you generally want to create a scheduled maintenance routine that will maintain your statistics, update your statistics on a regular basis, and then also update your indexes on a regular basis. The other thing that we see quite often is indexing that has really been done in a haphazard manner, meaning that maybe very few indexes were originally created. A query was performing slowly. Management Studio suggested a vast improvement if you would just create this index. And so a lot of people will create that index. And then later on, Management Studio may suggest another index that is very, very similar or even identical. And so we often see that there are either unused indexes in place or duplicate indexes in place, or some that could be combined into one index. The more indexes you have, the better it can perform at times, but they come with a penalty as well. The indexes have to be maintained. So statistics and index jobs that will rebuild or update the indexes as needed can be very helpful, but then also reviewing the number of indexes you have and what they're defined as. SQL Server will, when it makes changes to a data file, it'll write that data to the disk, and it hands that off to the disk and assumes that the disks wrote out everything as it should be. Unfortunately, sometimes things can become corrupt along the way, and SQL Server may not know that this become corrupt, that a data file has some corrupt data pages in there. Those can lie dormant until they can cause a problem. And that problem may be recognized pretty soon, or it could be recognized days or even months or longer later, in which case recovering from that can become more and more difficult as time goes by. So we definitely recommend a recurring, typically on a weekly basis, scheduled job that will verify the integrity of each database and ensure that data files or data pages have not become corrupt along the way. We also recommend doing test restores and then doing a data integrity check on those test restores periodically. We recommend using proactive monitoring tools. We've used a lot of different ones from a lot of different companies. We use typically whatever is in use at our customer sites. If one's not in use and one is warranted, we definitely recommend SQL Sentry by a company that was formerly called Sentry One, but now they've been acquired by SolarWinds. We also, additionally, we also have something called SERO Shield, which is our own product that does something somewhat similar to Sentry One on a smaller scale. Just as powerful in many respects, and it also helps us to do with our next item, which is daily health checks. In the SQL Server world, no news is not necessarily good news. Just because the monitor is not highlighting an issue doesn't mean all is well. And so we do recommend, in part of our SERO Shield product line or service, is logging on and looking at all the different key factors within SQL Server to make sure that it is performing well. So we look at all the SQL agent jobs, we look at the SQL agent error logs, the SQL Server error logs, the Windows error logs, and a bunch of like 80 some odd other factors to make sure that the SQL Server is healthy on a daily basis. Lastly, let's talk about some of the core business issues that we frequently see. And these typically are a little more at a higher level than some of the other configuration items that I've mentioned. One is when we ask about the backup and restore and retention strategy. Unfortunately, what may be in place at times is not necessarily consistent with the overall business needs. And so having a comprehensive perspective on how long are you required to keep data, either contractually or because of regulatory concerns, and what does the business need from you on that. And so are you backing up in kind of a two-stage process where SQL Server is backing up to a local drive, and then that drive's being archived off by something else like Commvault or something, and is captured and maintained for a period of time? Those are questions that'll be good to talk through and ask. Additionally, it's important to understand that a good backup strategy is okay, but really what you need is a good restore strategy and understanding how to recover from a failure that's going to be critical. Speaking of which, RTO and RPO, often those are not well defined within an organization. So by RTO, we're talking about recovery time objectives, how long it will take for you to get a SQL Server that has had a catastrophic event happen back online, or just a database, maybe not the whole server, but how long can you afford to be down on a particular data system. RPO, recovery point objective, means how much data can you lose. If you're doing nightly backups and you're doing those at 2 a.m. and at 2 p.m., the system crashes and you have to recover, is it okay to lose data back to 2 a.m. that morning? And if so, great, you've got it covered. But if not, then you need to look at other possibilities, maybe doing differential backups throughout the day or transaction log backups every 10 to 15 minutes that will allow you to get closer and narrow that window for potential data loss. Additionally, understanding the requirements of the business around high availability and disaster recovery. So if a system becomes unavailable for whatever reason, do you need to have a failover capability so that there is no disruption noticed by your end users? Do you need to be able to fail over through an availability group or a failover clustered index instance or something like that? And then again, what is your plan for disaster recovery, either from the system, the database itself, the SQL Server itself, or your entire VMware host or data center? Understanding and having a plan for that is going to be extremely important. You don't want to obviously invent the plan as it becomes necessary. A lot of our customers will have quarterly DR tests, and over the weekend they will go through an entire DR system test and refine it, document what went well, what went poorly, refine their plan, and then try it again in the next quarter, just to make sure that everyone is on the same page and can recover from a disaster as quickly as possible. You also want to, of course, look at the security considerations. Who has access to your data? What kind of access do they have? Are you doing any logging on that access? Do you need to do logging on that access? Are you governed by other regulatory or legislative requirements, HIPAA or SOX or whatever? So those are the areas that we see that may have a mismatch between the business objectives and needs and what's being done with the SQL Server. So I do have some additional resources for you. These are some articles that we've made available. Why most servers aren't configured with industry best practices. How do you know if your SQL Server is configured properly or not? What should you do with those servers that are out of support? Before adding hardware, we list some things you may want to check first that may save you some money. Show a few ways on how to adjust or query the Windows Power Plan, and then how to identify where your TempDB files are and how many you have. So the takeaways from today, I would suggest, take a look at these items that I've mentioned. Examine your SQL Server configuration. Look to see if they are aligned with industry best practices, and if not, is that intentional, or is that maybe over time the configuration has drifted, or the hardware resources have drifted, or something else? And then make plans to remediate those areas of discrepancy if needed. Review your maintenance plans and jobs. Make sure you have the appropriate ones in place. Implement other procedures and policies, change management, those other areas that I've mentioned. Make sure you're aligned with the business requirements. Review your security aspects. And if there are any problems uncovered in any of those, take the time to drill down and look at each of those. So with that, that's kind of a bird's eye view of some of the things that we see in doing our SQL assessments. I wonder, as we draw to a conclusion here, what questions do you have about anything that we've talked about so far? You can either put those in the chat, or I'm not sure, Oakley, if we can unmute at times and talk.
Yes, if you have any questions, you should be able to unmute yourself and also be able to put them in the chat, correct?
Okay. So any thoughts or aspects that you'd like me to elaborate on?
I do have a question, if it's okay for me to ask.
Absolutely.
Most people that are SQL and SQL servers, any servers, or mainly SQL or Exchange, you know, it's always best practices if it's a physical server. Of course, with physical drives, you separate your log files because, you know, of course, they're linear, and then, of course, your database files. So you separate them on different drives because the pattern of access. But that kind of gets muddy when you follow through the VMware. And then even at that, not even VMware wise, say you got a SAN that is a big SAN, and it's tiered, auto tiering. You know, you got three different levels of tiering, and is it still best practices to create different volumes on your SAN to separate your log files? Is it irrelevant, or, you know, it's kind of muddy there. Also, in VMware, you don't have a lot of control over which drive it's going to hit. So you have this big volume, and, you know, so you try to create two different virtual drives. Well, are you really doing anything if they still sit on the same volume? Now, honestly, I know you can go inside the VM and create separate controllers and maybe get a little more performance, but that's not the same type of performance. That's not random access. That's just, you know, going through a controller. That's not the same type of access as physical hard drives with heads moving. So what do people in my database right now on a SAN? I don't have them separated. Now, of course, if I had them on a physical drive with a RAID, I would separate them. But what's your opinion on that? What's anybody's opinion on that? In virtual worlds and in the SAN world, where you have an auto tiering SAN.
No, Trey, you're absolutely right. In that, in a virtualized world, or even to further complicate things, in a SAN or network storage device type world where things are not necessarily one for one, it does get a little more complicated about where the data actually exists, and is there any benefit to breaking those out.
Right.
So generally the recommendation, you know, is a C, you know, your operating system in binary on C, maybe your data files on D, your log files on E, your TempDB on F, and so forth, right? And generally speaking, that's what we still recommend, even in the nebulous world of SAN and virtual machines and so forth, for clarity and for
consistency, I guess.
Consistency and so forth.
Sure.
There, you know, when we talk to SAN administrators who are adamant and say, you know, I can do that for you, but it makes no sense whatsoever. Right. Well, that's not a hill we're going to die on, right? They're right in that case. But generally speaking, for consistency, clarity, and so forth, we generally recommend just going ahead and spreading them out.
Okay, I'm more of an infrastructure guy, so I'm the guy asking the question. I'm not a DBA, so I'm not sticking to my guns and saying this is how it goes. You know,
exactly. You know. It does matter a lot less when.
But consistency is important too. I mean, whether it's understand that too when you configure servers, you want to be consistent, and I understand that. I get that.
And as an example, we had a customer just last week who was in a situation that you just kind of described, which is virtualized SQL servers with a SAN on the back side. So it really didn't matter a great deal whether or not they separated it out. They happened to separate it out, and that SAN had a bug in it that once it reached a certain level of activity and access and a lot of other stuff, it corrupted the entire SAN.
Ouch.
And they are still recovering from it. Fortunately, the backup routines and everything else with SQL Server, they lost the VMs, lost everything. Fortunately, the backups that we were doing for them were stored off of that SAN, and the INI files were still persistent, so we could just essentially set it up exactly the way it was. The SQL Server configuration INI files, we could set it up exactly the way it was, and they were able to get back at SQL Server back and running relatively quickly. They're still having some pretty major issues with their database stores a bunch of image files outside of SQL Server with pointers inside of SQL Server to the external world, the file system.
They're syncing those back up. I got you.
Yeah, those are
pointers.
Those are the pointers are fine. SQL Server's fine. The images are about a third of them are corrupt, and they're trying to figure out, what to do about that. That's outside the SQL Server.
That's that. Yeah, exactly.
So,
well,
good question. Other questions or comments? Well, if something comes to mind a little bit later, feel free to shoot me an email. Love to hear from you. Always answer emails. It may take me a little bit of time depending on where I am and what I'm doing, but always respond. Feel free to shoot me an email. Some other social media type stuff there you can also connect with me on. And as we wrap up, I guess, Chris, do you have some departing wisdom for us?
Sure, not about wisdom, but certainly thanks for joining us for our presentation today. If by chance we were unable to get to your question, or you have any other questions concerning this topic or any other topic that we could help with, please feel free to reach out to us at the contact information on the screen. We do hope that you found this information beneficial, and we hope to see you again on our next webinar. As a reminder, our final webinar in this series will be coming up on August 17th. So be on the lookout for your invitation, and we hope to see you there. Thank you so much, and have a great rest of your day.